But let's talk about what happens when we put something on an inclined plane. Or actually, let's hold that for next time. Let's do a little check question. See if you guys are grasping this so far. Let's do. Let's say I've got some blocks. I'm pulling on some blocks that are on frictionless surface. So we've got block A. And we've got 2 blocks. They're all identical. All my blocks are identical. And I've got 3 blocks here. D, E, and F. Okay. Frictionless surfaces. The blocks are all the same. And the pulling forces are all the same. Okay. So tell me rank the blocks on the basis of the acceleration. Which ones are going to have the greatest acceleration? And which ones are going to have the least acceleration? And if any of them have the same, indicate that somehow. Are there any that we know for sure are the same? B and C are tied together, right? So they're going to accelerate at the same rate. And how does the acceleration of A compare to those? Compare to B and C? More, right? Twice as much? Is that what somebody said? And how about D, E, and F? They're going to be the same, and they're going to be and they're all going to be greater than 0, right? I like to include 0, but I won't worry about it the same. And the reason here is the acceleration is the net force over the mass, right? So for A, all 3 situations have the same net force. For A, we have F acting on a single mass. For B and C, we have the same force, but we have 2 masses that are being accelerated by that force. You see that? That same force is responsible for accelerating both B and C. And for D, E, and F, same force over 3 masses. So it's 1/3 of what A is. Yes, if you were trying to get B and C to have the same acceleration as A, that would have to be twice the force as the one on acting on A alone. And for D, E, and F, it would have to be 3 times the force acting on A alone. Okay? Any questions? All right, we'll see you next time.